This video continues with our chapter on polynomials, and this time we're going to look at multiplying polynomials. The beginning, when we are multiplying monomials, is something that we've already done in our section on exponents. But just as a reminder, if you are multiplying two monomials, meaning single term polynomials, you multiply the like parts by following the rules for exponents. So 6 times 4 is 24, x times x is x squared. Negative 7 times 2 is negative 14. X squared times x to the 5th is x to the 7th. You add those exponents when you multiply like bases. And finally, a negative 12 times a negative 1, remember that implied coefficient there is a positive 12. And then we have an x to the 5th times an x to the 1st is an x to the 6th. So multiplying monomials, pretty straightforward. Let's now look at multiplying monomials by polynomials. So we are looking at the distributive property. So again, our product rule comes into place. 7x times x squared is 7x cubes. 7x times positive 2x, positive 14x squared, and finally 7x times positive 5 is 35x. So just using the distributive property. Here we are distributing a negative 3x squared times 5 is negative 15x to the 4th. Negative 3x squared times positive 6x, negative 18x cubed, and negative 3x squared times negative 1 is positive 3x squared. In this next one, I'm going to use two colors to sort of help you follow along. We are multiplying a binomial, which is our first polynomial, times a trinomial. This is a double distributive property. So with blue, I'm going to distribute that m squared, and then with pink, I will multiply the positive 5. So we start out m squared times 4m cubed is 4m to the 5th. And then m squared times negative 2m squared is negative 2m to the 4th. Then we have m squared times positive 4m is positive 4m cubed. Now, that is when I distributed the m squared. Now what I'm going to distribute is I'm going to distribute this positive 5. So positive 5 times 4m cubed is positive 20m cubed. Now I want to show you where I'm going to write that. I'm going to write it underneath the one that is its like term, the m cubes. Now positive 5 times negative 2m squared is negative 10m squared, and positive 5 times positive 4m is positive 20m. You'll notice those last two didn't have anything that matched with them. Combining like terms, we get 4m to the 5th minus 2m to the 4th. Here we have a plus 24m cubed minus 10m squared plus 20m. It's a very long answer, but all we did was do a double distributive property. And that comes into play when we come to this next method, which is called the FOIL method. And it's when you are multiplying two, I'm going to change this, binomials. We use FOIL. FOIL is an acronym: first, outside, inside, and last. So in this case, our first is the first term in this parentheses times the first term in that parentheses, which is m squared. Our outside is the ones that are furthest apart. So m times positive 6 is 6m. Then we go inside for the I, that's the positive 4 times the m. So now I'm going to distribute that positive 4, and that is 4m. And finally, the L stands for last. So the last one in this parentheses times the last one in that parentheses is a 24. Again, I can combine my like terms, and I get m squared. These two are alike. plus 10m plus 24. Now, it's not necessary to write it like this each time. I'm going to show you down here the way you really need to write these. So we say, first, 3x times 2x, 6x squared. Outside, minus 15x. It was a 3x times a negative 5. Inside, positive 4x. Remember, you're multiplying. And last, positive 2 times negative 5 is negative 10, which gives us 6x squared minus 11x minus 10. Notice that, once again, my O term and my I term were alike. That's not always true, but it is often true. Let's try another one. First, outside, inside, and last. And I do recommend drawing those little lines like I did so you don't forget anything. Combining like terms, x squared, negative 5x and positive 7x plus 2x minus 35. Again, first, outside, inside, and last. Negative 3 times negative 4 is positive 12. So we end up with x squared. A negative 4 and a negative 3 is a negative 7x. Remember, after you multiply, you are then adding, combining like terms, and plus 12. So it is multiply, 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 combine like terms. First, outside, inside, and last. Negative times negative is a positive. Combining like terms gives us 5x squared minus 17x plus 14. This one is a little different. First, y squared times 2y is 2y cubed. Outside, y squared times negative 1 is negative y squared. Inside, positive 6 times 2y is positive 12y. And last is negative 6. Now when you look, the O term and the I term are not alike. There's nothing to combine. Those were all 4 different terms. Doesn't happen a lot, but it can happen. Let's look at this one and see if you see a pattern where you are multiplying a binomial times itself. So we have first 2x times 2x, 4x squared. Outside, minus 2xy. Now inside, I know the y comes first, but since I'm just multiplying, I'm going to write it the same way as I did this one so I know that they match. And then negative y times negative y is positive y squared. Combining my 2 like terms gives me 4x squared minus 4xy plus y squared. So that was multiplying a binomial times itself. And we're going to look at a little bit more of that on this second page, where we have a section called squaring binomials. Squaring means times itself. So here I have x plus 4 squared. And although it's tempting to think that that's just going to be x squared and 4 squared, it is not. Because of that plus, what you have to do is write it twice. Write it twice. So we're going to write x plus 4 times x plus 4, and now we're going to FOIL. First, outside, inside, and last. Notice that the O and the I are not only like terms, they're the same term. We get x squared plus 8x plus 16. When you multiply something times itself, or when you square a binomial, your O and your I will always match when you multiply exactly times itself. So let's try another one. Again, write it twice. So it's y minus 1 times y minus 1. FOIL, y squared minus 1y minus 1y plus 1. Negative 1 times negative 1. That gives me y squared minus 2y plus 1. Notice again the O and the I were the same exact term. So in general, if you were squaring a binomial with a plus in between, you're going to get the first one squared plus 2 of them multiplied together, 4 times x, 4 times x. Here it was negative 1 times y, negative 1 times y, plus the last one squared. And if you're multiplying a binomial with a minus in between, you're going to get the first one squared minus 2 of them multiplied together plus the last one squared, because it's a negative times a negative. You don't have to memorize this generalization, but it is a pattern that does show up. So let's try these. You can either try using the rule. I don't recommend that. I recommend that you write it twice. So we would have t plus 2, t plus 2, t squared plus 2t plus 2t plus 4, which is going to give us, I don't have much room here, t squared plus 4t plus 4. The o and the I were the same again. Here we would have x minus y times x minus y, x squared minus xy minus xy, and then your last plus y squared. So x squared minus 2 of the 2 multiplied together plus the last one squared. This one you need to be careful of. 2x plus 5, let me scoot this over, times 2x plus 5. First is 4x squared outside plus 10x inside plus 10x. And last, plus 25, or 4x squared plus 20x plus 25. The pattern holds, but it's always safer to write it twice. Finally, let's look at this one. X squared minus 7y times x squared minus 7y gives you x to the 4th minus 7x squared y minus 7x squared y. Notice I wrote those alike, even though they're out of order. It doesn't matter. Plus 49y squared. The o and the I again are alike, and we get x to the 4th minus 14x squared y plus 49y squared. So that is squaring a binomial. We're going to look at the last thing here, something that is similar to squaring a binomial, but not. So let's look here at example 6. I am multiplying something times itself, except one is a plus and one is a minus. So watch what happens when you FOIL that. You still get the first one squared. Outside is minus 2x. Inside is plus 2x. And last is a positive times a negative is a negative. So my o and my I, rather than being the same as they were when we squared binomials, here they are opposites. So they zero out, and you end up with just x squared minus 4. It's a great pattern to memorize. It's an easy pattern to recognize. Multiplying something times itself when one's a plus and one's a minus. The o and the I will always zero out. So in general here, where the star is, if you're multiplying a plus b times a minus b, it's always going to be that. Because again, the middle terms will zero out. So here, I really don't even need to FOIL it. I know it's going to be x squared. That's going to be a minus, this is going to be a plus, so they're going to zero out. Minus 16. It's the easiest ones of all to do. Here it's going to be 36t squared minus 49. O and the I zero out. There are 4 problems here for you to try on your own. And if you have questions, you can bring those to class.